All right, in homework 9.1, we're now solving exponential equations, which is really what we learned logs for more than anything else. I'll do a few of these with you to make sure we know what's going on. Start with number 5. Let's see. So we've got 2 to the x power minus 5 divided by 3, and this is equal to 9. So we want to find what x is. So the first step is to isolate this exponential. We want to get 2 to the x by itself in an exponential equation. So we need to undo it. We need to treat this like this was x minus 5 divided by 3. The first thing we're going to do is undo the last operation that happened, which was dividing by 3. So we multiply by 3 to cancel out the dividing. 2 to the x power minus 5 equals 27. We then add 5 to both sides. And we get 2 to the x equals 32. Now, there are 3 ways to do this. The first is you can just think to yourself, 2 to what power gives you 32? And the answer is 5. 2 to the 5th power. 2 times 2 times 2 times 2 times 2 gives you 32. And for easy ones like this, it's completely reasonable to do it like that. And so you could just say x equals 5 from here. For harder ones, this method will not work as well. Let's look at another one. We could do rewriting in logarithmic form. So if you have 2 to the x power equals 32, then log base 2 of 32 gives you x, because this is saying 2 to what power gives you 32? The answer is x. 2 to what power gives you 32? And the answer is x. So then you can evaluate this logarithm. 2 to what power gives you 32? The answer is 5. The last way, I'll redo it over here, is, and this is how I think about it. This is what I do, is I think, okay, 2 to the x equals 32, and I just do inverse operations. You know how when you have x squared, you do square root on both sides? Well, when you have 2 to the x power, the inverse of an exponential is a log. It's the same base as whatever this is. I'm just going to do log base 2 on both sides. And what happens is, log base 2 cancels out the 2 to the x, and you just get x equals log base 2 of 32, which is 5. Whichever way you do it, you're going to get 5. We'll see when we get to slightly harder ones that this won't work as well. Number 12 is my favorite, so we'll do that one, make sure we know what's going on here. On number 12, we have an absolute value equation, but it's in an exponent. So there's an absolute value inside of an exponential. The first step is we're going to need to get that exponential by itself. So just like before, we're going to add 47. 50 equals 2 times 5 to the absolute value of 2x plus 4. Then we're going to divide by 2 to get rid of the multiplying by 2. 25 equals 5 to the absolute value of 2x plus 4. Now that we have the exponential by itself, we can cancel out this exponential by doing a log. I'm going to do log base 5 on both sides. Although, again, you could just think, what does this exponent need to be to get to 25? And you would get, well, this exponent needs to equal 2. Either way, log base 5 of 25, 5 to what power gets you 25? The answer is 2. And so that's what the absolute value of 2x plus 4 is. Now you need to remember how to solve absolute value equations. Well, this thing inside of the absolute value is going to get turned positive. So the thing inside of the absolute value could either be positive 2 or negative 2. So we're going to write that. 2x plus 4 could be 2, or 2x plus 4 could be negative 2. Because either way, the absolute value will turn it positive. That's how we solve absolute value equations. And so the last thing is to solve this linear equation. We subtract 4, divide by 2, x is negative 1. We subtract 4, divide by 2, x is negative 3. Those are our solutions. On the back, this time, these are ones that cannot be solved by hand, except that you can leave it in simplified form. So let's look at how I'll do number 5 again. The way this goes is you solve just like normal. You subtract 8. 7 to the negative 3x plus 1 equals 5. You take the log base 7 on both sides. And this is where things get different. So log base 7 cancels out, negative 3x plus 1 equals 7 to what power gives you 5? There is no exact answer that gets you this. This is an irrational number. Just like the square root of 7 is an irrational number, log base 7 of 5 is an irrational number. There is no, it's an infinite non-repeating decimal answer. And so it's fine in math just to leave it as log base 7 of 5. That is the simplified answer here. It's like point something. I don't know. Then you subtract 1. And we have to be careful that we don't make any math mistakes here. Like some people try to subtract 1 from 5. You can't do that because the 5 is inside the logarithm. We just write log base 7 of 5 minus 1. The last step is to divide by negative 3. And that is the answer. X equals log base 7 of 5 minus 1 divided by negative 3. It is completely fine to leave your answer like that. If you wanted, dividing does distribute, and so you could say x is negative 1/3 log base 7 of 5 plus 1/3. And if you really wanted to, you could use your properties of logs to say x equals log base 7 of 5 to the negative 1/3 power plus 1/3. And negative 1/3 power means log base 7 of 1 divided by the cube root of 5 plus 1/3. You are welcome to stop right here. This is good enough. But this is some high-level math going on right here if you get all the way to there. The only other one I want to point out is this last one. This is an exponential hidden inside of a quadratic. You can tell, I'm going to give you a hint here, but I'm not going to solve the whole thing for you. You want to let a equal 2 to the x. And that will transform this into a squared minus 5a plus 4 equals 0. When you figure out what a is, you need to plug it back in and solve that log equation. I hope that helps on your homework. Good luck on the rest of it. Feel free to come into tutoring if you still need help.